Welcome to The Virtual Shift, a show looking at the seismic changes happening in healthcare with virtual care at the epicenter. Join me and my guests as we look at key cultural and policy shifts impacting how providers, payers, and patients connect, as well as how care is being reimagined both for today and the future. Hello, and thanks for tuning in today. I'm your host, Tom Foley. You can learn more about this show by visiting the program on healthcarenowradio.com, and be sure to follow me on LinkedIn, Twitter at FoleyTom, and the hashtag The Virtual Shift. And today we have a very special guest, Maria Valero. Maria, welcome to the program.
Thank you. Happy to be here.
Awesome. Maria is a representative of Kennesaw University out of Georgia, the College of Computing and Software Engineering and Information Technology. She is the Assistant Professor of Information Technology and Director of the Internet of Things and the Service Research Group.
Yes.
I appreciate you joining us on the program today. There was a very interesting article that was printed that involved you relative to one of the very compelling projects that you're working on that I think will impact significantly patient monitoring, specifically as it relates to glucose measuring. So before we talk about that, tell us a little bit about Kennesaw University, your department, and ultimately the project in which you're engaged.
Right. So yes, I work for Kennesaw State University. This is the second largest university in terms of enrollment in Georgia. So my college is one of the biggest college on campus. That is a College of Computing and Software Engineering. And inside of our college, we have 3 departments and 1 school. And one of the departments is the Information Technology Department. That is the department that I belongs to. And so my group is inside this department, is Internet of Research as Service research group. And what we do basically is develop non-invasive technologies for healthcare. So we have a series of projects related with devices that monitor those devices monitor healthcare and certain parameters, vital signs, etc. And we have a very strong project right now that is related to glucose monitoring. So we have developed, with the help of the college and the university, we have developed a non-invasive device that can measure blood sugar without blood and also without inserting any type of needle in the body. So we are using only a kind of light that go through the extremity of the person, and it could be finger, it could be earlobes, right? And with that light absorption, we are able to take some images that we then later convert to the glucose value through the use of some artificial intelligence algorithms. So that is what we are working fully right now.
Very interesting. So, everyone knows, especially those with diabetes who actually monitor their glucose level on a daily basis, one of the major inhibitors to actually performing that simple task, if you will, simple but complex in the context of they're constantly pricking their fingers for that blood sample, and a non-invasive meter would really change the whole framework relative to the patients in this particular category. Talk to us about the current model of pricking the finger, the more enhanced model of the continuous glucose monitor that goes, typically you would see based on the inserted on the back of the bicep typically, and versus a non-invasive glucose. There's certainly some benefits and negatives to each one of them. Can you outline them for us?
Sure. So, to give you a background about the technologies for glucose monitoring, we have, of course, the invasive technologies, the minimal invasive technologies, and the non-invasive technologies. So the invasive technologies are those related to extracting blood, but it's actually extracting blood from the vein. So it is when you go to the lab and do your annual checkup with your doctor, and they extract blood, and they actually do some lab process on the blood and extract your blood glucose. Of course, that is the most accurate value, but that is the most invasive one, right? Because you actually need to extract a certain amount of blood to run certain chemicals in the blood. We have the minimal invasive devices that are the typical devices that people with diabetes use. That is the glucometer that basically requires the finger prick. That typically they just take a small sample of blood, and they use this sample of blood in a glucometer device and give you the estimation of the blood sugar at that moment. The problem with that devices, as you mentioned, is that people with diabetes typically needs continuous monitoring. And the most continuous that they can do with this type of devices is, using it multiple times per day. The other day I was talking with a person with diabetes that it was a young student in our college, and he told me that he needs to do this around 10 times per day, which is a lot. And they've end up with a lot of problems in the fingers, lost of sensitivity. They have certain scars sometimes. So with the time, and you know that diabetes is a long life disease, right? With the time, it's worse and worse and worse in terms of getting this sample, even though it's a minimal invasive. So people came with new technologies also in the minimal invasive spectrum. That is this new continuous monitors that you can place on your arm, and basically they insert a small needle. It's a subcutaneous needle that is basically reading the glucose continuously. While it's a good thing because they can have multiple readings without, do the fingerprint, right? The problem is that produce with the time, that can produce some infection in the skin. And especially for senior population is very difficult because they actually, the sensor needs to be changed every 2-3 days. They actually need to insert the needle again. And also the problem is that they are so expensive. It's not a affordable technology. So we came with a non-invasive. In the spectrum of non-invasive is using other type of fluids to get the value of blood glucose. So in the research area, this is not in the commercial area yet, but in the research arena, there are many research related with this. So some people have calculated the blood glucose from tears or from sweat or even from saliva and from urine, right? The problem with these technologies is that you actually need the fluid, right? You need to cry, or you need to sweat, or you need to go to the bathroom. So it's not an easy process. So we are different because we are not using any fluid. We are not using any blood. We are not using any minimal invasive or invasive technology. We are using only light. And what we do is that we use some light that go through it. Let's put an example of the finger. When you put that light on top of your finger in a very small camera on the bottom of your finger, we are able to get images that measure the absorption of that light by the absorption that is possible to get from your extremity, right? And we know that we can be able to extract the glucose molecule from that specific image. So we develop a model that basically read these images and estimate the glucose concentration in that image. And that is the one that we are getting as a result. And it's very comparable with the other types of glucometers or of techniques currently on the market.
And how accurate is a glucometer today that's on the market? Any rough idea?
Well, those the FDA has some requirements, and also there are some ISO rules for this type of devices. So they need to be around, to give you a percentage, is like 15% plus or less of the value, the real value. So those devices are accurate, but not as accurate as the invasive itself. But that small error that they have is acceptable, is clinically acceptable. So they are typically the glucometers on the market, they claim more than 95% of accuracy, and some of them claim less, but everything around the 90-95% is what they claim. The other devices, the ones that you put in on your arm, they claim also very high accuracy, 95-98% is what they claim.
And so I believe you're taking your product and bringing it to the market as more of a what I would classify as a wellness device. You're not looking to get FDA 510K clearance just yet. Is that fair to say?
Well, the first step that we wanted to accomplish is to have a very high accurate device, right? And to be tested as widely as possible. And we wanted to put it on the market at the initial stage as a consumer product, so they can use it without diagnostic purposes, right? So it's just monitoring purposes. But our long-term goal is, once we have a very wide use and very wide verification of the models that we have, and of course improvements that we are doing at this moment, we wanted to apply for FDA, the FDA process, which imply a lot of time, right? So the FDA process is not something quick. And if you want to put it on the market as soon as possible, you want to target first the consumer product area. Yeah,
I would imagine from a consumer product area, as you enhance your algorithms and increase the value, given the impact of a non-invasive device, whether there's any accelerated path. But that's my pure speculation on that particular effort. I just know that my father was a person with diabetes, and and I know the many struggles that my audience has heard about many times. But measuring it is the first step to awareness and action. So very, very interesting. So there are other devices, as you know, and then as stated in this article, and the article is entitled "Sensor Breakthrough Brings Us Closer to Blood Glucose Monitoring on Wearables," and it's obviously all about your product, which is referred to as the what is the name that you gave your product?
GlucoCheck. Yeah.
The GlucoCheck, exactly. But there's other products on the market. Apple's obviously been talking about non-invasive for a while, and there's Samsung has done the same. Nothing's really truly out there yet. Any insights relative to what makes your product a bit different than what others have been proclaiming to do in the context of non-invasive glucose monitoring?
Sure. So yes, as I mentioned before, there are many other attempts to facilitate the process of monitoring glucose in people with diabetes, right? What we believe that we are different is in the mechanism that we are using to estimate the glucose. We have a model right now that with minimal computational effort is capable to get almost 91% of accuracy. And we believe that we are making this into the next step to get better accuracy than that. The other thing that we are targeting that maybe other technologies are not targeted right now is that we are also evaluating the specific aspects of the skin that impact our model. For example, if you have an Apple Watch, and the Apple Watch, of course, use light to estimate some values on your body. Let's not talk about glucose, but let's talk about heart rate, for example. They use some PPG information from using light, but they haven't studied in detail, or at least I'm not aware of how skin pigmentation affect this, right? Is light, is penetration of lights. So the skin color, the skin thickness, the skin roughness, the skin wrinkles, all those kind of factors affect the result, and it's impossible that you say that is nothing to do with that. It is, right? In some of them in high value, some of them in low value, but they actually modify something. So we already studied that pattern too, and we can customize our device depending on your skin properties. So what we're trying to do is, like, later a person with and with from different races, different ages, different genders, they can actually customize the device to make their readings as accurate as possible, right? So that is one thing that is unique what we are doing. And also the other thing that is unique with us is that, well, of course, we have a mobile application that show you in real time. That is not new. Every other um, device currently on the market, they allow you to visualize your results via mobile app. We have that, of course, but we are working in a very good new model that is, well, I'm going to give you the first look of this, but we are also looking into a help on estimate how your blood glucose is going to behave if you eat something or do make some exercises. So for example, I wanted to eat an apple right now. So I can ask my glucocheck how my blood glucose is going to behave. And this is not going to be a standard thing because everybody is different. So for you, eating an apple may not do anything on your blood sugar, but for me, for example, it could be a killer, right? So we are working in that kind of technology to incorporate in glucocheck.
So let me be clear on what you just said. You're normally I have to wait to eat the jelly donut to see how it impacts my blood sugar, right?
Exactly.
Yeah, and you're suggesting that your app, you could estimate. You want to say, hey, I want to eat a jelly donut. What's the impact of my glucose level?
Correct.
That's what you're researching right now.
Right. Correct.
Wow.
That is what we're doing.
That
Cool feature.
it's really a buzzkill because I really want to eat that jelly donut. Right? That's what the
and it's going to actually help in other conditions, not only blood sugar, glucose itself, but also in fitness related or also in obesity, right? When you are aware of what the food is doing to your body or the exercise is doing to your body with this specific value of glucose, right? You can raise the awareness, right? Of like,
right.
drinking this Coke is going to do this to my body, right? So people could be more conscious of what they eat. And this is a long-term project. This is not only the device, this is a actually game changer that we wanted to do. And we also are looking and thinking a lot of different type of people with certain conditions too, because for example, think about people that cannot see, blind people, right? So they cannot use the app. That would be very complicated for them to actually look at the app and see the tendency and whatever the blood sugar is behaving. So we actually connect right now that the technology is ready. We have voice assistants connected to glucocheck directly. So the person who is using the device to know the blood sugar, they don't need even to look into the app. They can ask the Google Assistant or the Amazon Assistant, how is my blood sugar now? And the assistant can reply, your blood sugar is this at this moment, right? And how was the behavior in the last week, in the last month? So we have all that features ready. There is not an integration for a commercial purposes yet, but there is an integration in terms of research already done. So I think we are unique in that perspective. And this is something that we want to expand. It's not just the created the device and that's it, take it, right? It's just make it grow and grow in a huge project that can actually, cover many things, many aspects of the glucose and of the in many aspects on diabetes.
I would agree. I mean, we're very much involved in remote patient monitoring and things of that nature, but to be able to anticipate or project is the better word, what might happen if you exercised or ate that jelly donut or drank that can of Coke. That, again, my father used to drink Diet Coke in the contribution to his diet. He was very, as I said, a diabetic and a very, very big person. But the point is that, yeah, it'd be a great assistant to have on your wrist or your smartphone to help you. Don't eat that jelly donut. I told you so, right? But I joke a little bit. But the point is that this is what consumers need, what patients need. They need engagement. And sometimes, the doctor isn't always going to be there. The nurse isn't always going to be there. The caregiver isn't always going to be there. This is a great assistant where, as trust is built between the platform and the person, there's going to be behavioral changes, and that's ultimately what we need if patients are going to move from this level of awareness to level of wellness, right? Is
Right.
behavioral change.
Right.
And the more they can get that, the better. And I think your platform is very unique, not only in the context of non-invasive glucose monitoring, and very effective in the context of just nearing 91% accuracy in its measure. I think it's 90.7, if I recall the
Yes,
numbers
correct.
perspective, just for the audience's sake. We didn't grossly lift that number. So, and to add on this personal assistant, not only for glucose, but potentially for others elements of wellness, is, again, a complete game changer. So are we on the same page? Is that what I heard
Yes,
from your
exactly.
conversations? Awesome.
Exactly.
When do you think GlucoCheck in kind of its first out of the gate model might be publicly available on the market?
Well, yeah, so we are in that process right now. We expect to have a very robust model and probably in 1 year. But the most critical part, the model is fine. We can do it even earlier. The more critical part is to make the prototype very compact and easy to use, right? So that is, we don't want people to get complicated stuff that they need to press too many buttons or something like that. We want something simple, easy to use. So we are right now trying to find partnerships with some hardware companies that can help us to reduce size, make it compact, make it look pretty for users. So that is the stage that we are. If we get those partnerships in the coming year, I'm pretty sure that we can hit the market very soon. For the other technologies that we have, and we are developing some of them, that is related with the prediction, and that it will take more time, but it's something that we can integrate easily. So I think being optimistic with the whole product, including the prediction, we were maybe talking about 2 or 3 years that we can have some initial, let's say, market devices around there.
Very good. Well, listen, I think you are doing great work. My only hope is if we could accelerate that timeline, my own personal opinion, because I think this is a complete game changer, even if it was just the non-invasive glucose where I can press the button, measure it, and then jump for joy relative to the results of the measure. All right, that would be awesome. But I think you guys are definitely on the right track. I was very surprised at the article because of what you're based on your leadership, what you've been able to achieve. And I think it's, again, a game changer. And I didn't realize Crenshaw State University was even, involved in this type of thing. So helping raise awareness to my audience relative to what you're doing, and to keep better track what might be coming out of your university. I'll give you the last word.
Yeah, well, first of all, thank you so much for helping me to put this on people's mind, that they know what we are doing. They can see how this type of research can make in real life. Sometimes people believe, okay, they are in a university doing some research, but that they publish a paper and that's it, right?
Yeah.
So we are trying to do something different. We wanted to actually help others. And for the last thing that I want to say, we are in the process of improving the testing and all that kind of a stage in which we need help of people, especially in the Atlanta area. If you have diabetes, type 1 or type 2, doesn't matter, and you are willing to contribute with us, we are going to do a data collection round again very soon. I will, post on my website when. And if you are willing to volunteer to give your samples and to help us to improve the device, more than welcome for us. That is helping us a lot. When we start 2 years ago, we only have 70% accuracy, and with the all the volunteers that help us with data and more data, our model is more and more robust. So if people in that area, Marietta area, Atlanta area, if you are willing to contribute, just contact me.
Awesome. Very, very well. So I will leave it there. Maria, thank you for your time, and I wish you nothing but the best relative to the things that you do.
Thank you. Happy to be here.
I want to thank the show sponsors, HP. HP Engage Long Lifecycle Products provides the stability, safety, and security you need, plus flexibility and performance designed for today and tomorrow. As well, GenieMD, providing a modular, scalable, and customizable virtual care platform and clinical services to help providers extend care into the home, increasing access and quality while driving new revenue opportunities. If you missed part of today's episode, you can tune in at the same time, 11 a.m. or 7 p.m. Eastern, throughout the week, and be sure to check out the program page on healthcarenowradio.com. And remember, connect or follow me on LinkedIn, Twitter at FoleyTom, and follow the show's hashtag, The Virtual Shift. I'm Tom Foley. Until the next shift.